Hello everybody, we're on day 3 of Credit 9. So we're looking at the patterns that show up with these quadratic functions. So in the first day we looked at the suspension cable, had this sort of a pattern. So there was like something x squared minus x plus a number, right? And then we dealt with this one where we had the income for the concert was given the income equals x times this quantity here, and profit similar. It turns out that you can rearrange all of these expressions to be in this form: ax squared plus bx plus c, where you have your coefficient on x squared, your coefficient on x, and your constant that's by itself with no x attached. So we want to make use of this pattern to come up with how we can graph these. Okay, it's kind of like when we graphed our lines and we had y equals mx plus b. We saw that b was the y-intercept and m was your rate of change or your slope. Okay, so these three quantities do something. So we're going to look at it in GeoGebra. So I'll just go ahead and open GeoGebra right now. So there it is. And what they ask you to do is to graph y equals x squared, y equals 2 times x squared, and y equals 0.5 times x squared. And I think we could just throw a slider on there. So instead of doing each of those, you could do each of those in a different color, but I'm just going to make a slider. And you say y equals a times x squared. Okay, so that's a graph of y equals x squared, and if I want to find y equals 2x squared, all I have to do is move this a over, right? So I need to go on the move tool and move it over to 2. Okay, so what happens between 1 and 2, right? 1 and 2. So that's kind of the questions that you want to answer there is how are the graphs, what do the graphs have in common? How are the graphs different? So what's different, what's the same between a equals 1 and a equals 2? And then also when we go down to 0.5, what happens, right? So how is that different than when a equals 1 or a equals 2? And you could just do them in different colors. I could say y equals, or how about I use my function notation, f of x equals x squared, g of x equals 2 times x squared, and h of x equals 0.5 times x squared. Okay, and then you can change the colors of these. So I just right click on it, object properties, change the color to red for the first one, and green for the second one, and blue for the third one. Okay, so you can see them there, and I'll just make my a go down to 0. Okay, so you can see the difference between them. So g, f, and h. So f is the x squared, g is the 2x squared, and h is the 0.5x squared. So what do you think happens when we go to the negative? I kind of already showed it to you, but when we go to the negative numbers, we go down, right? So they want you to graph negative x squared, negative 2x squared, and negative 0.5x squared. So you can see those here. And compare those different graphs. Okay, back to the page. So that's what you're going to do there is graph the negatives. And what do they have in common? How are the graphs different? So what is the effect of the negative value when a is less than 1? What effects does negative value of a greater than 1 have? How does the curve change shape? Okay. So you can go to answer those questions. So why are the graphs always symmetric curves? The minimum point at 0, 0. So, well, 0, 0 is just a value that makes all those statements true, right? When x is equal to 0, then y is equal to 0, right? Now we're going to add a constant to it. So imagine now we have this quadratic function where it's ax squared plus some constant. So you could do that right over there in GeoGebra. I'll bring it back up. So let me just add another letter. I'll add a slider bar for C. Okay, and then for this function right here, I just need to say plus C, and all I did was double click on that in the algebra view. And so if I have plus C, what happens when I change different C values, right? And you can make those modifications. And we'll look back over here. So you can see here they add 3, and they subtract 4. So look at these different sets of possibilities and see what happens when you add 5 and you subtract 1 and modify them in that way. Okay, and then so answer these questions about how does it change when you change that C value, when you change that A value. What does the curve look like? And then it talks about factored form. Okay, so then we look at this factored and expanded form. So this has a factored form of a bungee jump, and here's the graph for it. So we have, you can see here that it crosses at 0, 0, and out here at 50. And that's the values that would make the I, income, equal to 0, right? 0 for P, 0 times anything is 0, and 50 minus 50 would be 0, so 0 times anything would be 0. So that's how you get those values there. So the factor form is good at finding x-intercepts, right? So over here, the x-intercept would be, well, 0, and what makes this 0? So I could say 4,000 minus 250x equals 0. So what value of x makes that 0? Subtract 4,000 from both sides and divide by negative 250, and you would get something, I think it's like 16 or something like that. Might be something a little bit more. Anyway, so you can do that for yourself, and then that would give you the x-intercepts again. So that the factored form really gives you a powerful tool in finding x-intercepts. So you can find the x-intercepts there. The y-intercept, right, is whenever the x value equals 0. So you plug in 0 for both of these and both of these spots, and you see what comes out. Right, so 0 actually times anything. So the y-intercept is going to be 0 and 0, right? The maximum point is going to be halfway in between, because we have, because we have two x-intercepts, halfway in between them is going to be the x value of the line of symmetry, right? So if you have 0 and 50, then halfway between them is 25. All you have to do is plug in 25, and you can find out what the value of the income would be when you plug in 25. So that would be the maximum point. Okay. So then we have kind of a full problem here where you probably will want to factor this yourself, and then you can answer these questions, right? That's the hint, is factor that yourself, and then you can use that information that you just learned to help you make a sketch of the graph. Okay, now adding a linear term. So the linear term is the b, right? Or bx. So go back over to GeoGebra. And now we're going to add in another term. So another term for b, right? So we put in b, apply, and we change this function to say ax squared plus b times x. And now we can kind of see what happens when we change b. Well, it looks like it shifts to the left and the right, but it always appears to go through 0, 0, huh? So you can play with that. And then finally we put them all together. So we have ax squared, or ax squared plus c, and ax squared plus bx. So what if we put them all together. So look at these three graphs, right? So C, remember, shifted it up and down. The B told me that it would put that second point out there, right? So and then you're going to answer the questions about these, right? So putting it all together, what makes a graph go through 0, 0? What makes a graph go through something higher or lower? And what makes a graph even go up or down, right? So put those three things together, and you should be able to pick out which of these curves are which equation over on this side. Okay, and then you should be able to sketch these graphs, putting that together. And it says without using graphic technology. So we're kind of getting away from using the GeoGebra now. So you should be able to graph this by factoring, right? X times x plus 4. So you know that the x-intercepts are at 0 and -4. And then it's shifted down by 6 or shifted up by 5. So those different graphs would show up on here. And you can sketch those. And then what happens when we have a negative in front of the x squared? Then it's just going to be a frown instead of a smile, right? And that's it. And then you're going to answer those questions in your math notebook.